I need to record. Thank you. So I'll just step a bit back. Suppose you're given a trigonometric function, let's say sine 150 or sine 190, wherever it is, and you want to simplify it. Remember, you can actually simplify it to like reduced value. You can do reduction of trigonometric values or function. So using reduction formula. So in that case, by the time you reduce it, you might end up having sine 45 degree plus 30 degrees to give, let's say, sine 75 degrees can be expressed as sine 45 plus 30 degrees, wherever way you want to reduce it. And if you now have those values, angles, given as 30 and 45, you can easily insert the value of such angle from this table, okay? Let's say sine 30 plus 45, then you'll be having sine 0.5. The value will be 0.5 plus 0.71, and that will give you the value of what you're looking for. It's just a way to quickly solve your trigonometric function. So you have all of these expressed, their values have been expressed, which is equivalent to the angle, all right? That's what we use this table for. We don't need to spend much time on that. I don't know why this is not fitting to page. But can we see it in this way? For me, it looks very small. Do I need to expand it? Okay, I think it's better like this. Now let's look at the graph of trigonometric functions. I'm sure most of you are familiar with the graph of sine and cosine, even the graph of tan. And the graph of cosine is like the opposite of the graph of sine. Let's look at this first graph, which is the first one, A, figure A. The dotted line represents the graph of cosine. And I will call your attention to something in this graph. Let's say you are told to draw the graph of a trigonometric function from 0 to 2 pi, okay? 0 to 2 pi, let's just do this, will be here. 0 to 2 pi will basically be from 0, it's here. I hope you can see this. And this is 2 pi, okay? Then what this simply means is you need to represent sine. Let's say you want cosine, right? Then it starts from here and it keeps going this way and it ends here. This is 2 pi, right? This will represent, this is how your graph would look like. Okay? And that is the dotted line, which will come from 0 to 2 pi. And the same thing applies to the graph of sine. Let's say you're told to represent your graph of sine function from 0 to 2 pi. How is it going to look? It's going to take this shape. Oh, sorry about this. I don't know why all of this is not working. That's fine. Okay, please ignore this line. It seems it's not going to be erased. But yeah, the graph of sine is the other one. And that shows you from 0 to 2 pi, okay? And if you want to represent from, let's say, minus pi to 0, and you want to represent um, the graph of cos, you're going to have from, let's say, minus pi to 0. You see, it's just the same thing like this. That will be this graph. And you want to represent, oh no, sorry, that's the graph of sine. This is the graph of sine. This is the graph of sine. Okay. And if you want to represent the graph of cosine from minus pi to 0, it's going to be from here to here. Okay. And that will be this dotted line. All right. This is the graph of cos. Okay. And it's from minus pi to 0. And this other one is from minus pi to 0. Okay, so I'm just trying to make you see how to represent your graph, and you need to observe the range. You need to pay attention to the range at which you're told to draw your graph. If you say, if I've indicated that, draw your graph from minus pi to pi, please pay attention to that and make sure you draw that, represent that function within that range in your graph, okay? That's why I'm trying to emphasize this. And the same thing with the graph of tan. You see the graph of tan is in this way, and if you have your values, you can actually draw out your graph. And the graph of cot, which is, remember, cot is 1 over tan, and that is why you have your graph facing the opposite direction from that of tan. All right, you have the graph of cosec and the graph of sec. By the time you practice, you'll be able to draw these graphs yourself. They are pretty straightforward. Now, we can have horizontal and vertical shifts of our function. And what this implies this. Okay, let's look at what vertical shift imply. Vertical shift can be obtained by adding a non-zero constant to the trig function. Okay, and these are examples. This first example, A, which is y equals, can I just open another whiteboard? Okay, share blank whiteboard. Okay, here we have y to be equal to sine x. And you want to have a vertical shift for this. What do we mean? What we mean is we can actually have sine x plus pi or something, or a, we call it something, a constant. This constant is going to shift our graph vertically. Remember, you have, when we talk about vertical, we have a line like this is vertical, a line like this is horizontal. So it's going to shift our graph upward. That's what we mean. Let's say sine x is this graph. Let's just do this. And if you want to have a vertical shift, it's going to shift it this way. Okay, that's all it means. An horizontal shift. Before we get there, let me go back to the slide. Just going back to the slide. I hope I'm not going too fast. If I'm going very fast, please indicate. So this is what I've drawn out there. When you have a sine graph and you have added 2, that 2 is the constant, which I've said is a or pi or whatever constant it is. This graph is going to shift vertically with the value we have added. If you add -3, can someone please tell me in which direction will this graph be shifted, and with what value will it be shifted on the y-axis? Suppose we have y equal to sine x plus, -3, not plus. Please, can someone just tell me? Okay, thank you. 3 units downward, and that's correct. So if you have minus, let me write it out so everyone can see what we're talking about. -3. So let's say we have y equals to sine x -3. It's going to be shifted in the negative direction. That's what we mean downwards, by a value of 3. Okay? And that is just a vertical shift in this case. And in the case of horizontal shift can be obtained by adding the same non-zero constant. Now it's going to be added to the angle of the trig function. All right, let's say we have sine, like we have in this case, sine x plus pi over 4. Remember, this is different from the other one we had here in the case of vertical shift. This 2 has not been added to the angle. It has actually been added to the function sine x itself. Okay, and that is for vertical shift. But for horizontal shift, you'll be adding the value, the constant, to the angle itself. As you can see, x plus pi over 4. Another example may be, I'm just going to write, another example may be y equals cos x minus pi itself. Okay, this could be another example. So when you're adding a constant to the angle itself, if it's going to be maybe a negative constant or a positive constant, but a non-zero constant, then you'll be having an horizontal, you'll be having a horizontal shift. Okay, I hope that is clear. And when you look at this, remember we have added pi over 4 to x, sine x. It's giving us a shift from minus outside, and then you also have it this way. So if, let's say, this value is 0, of course, we're not saying, we're starting from x is 0, and then you add in this value of pi over 4 to 8. You have, take note, please take note, that it will be starting from the negative side. If you are adding minus pi over 4, the shift will be starting from the positive side. That's important for you to note. All right, that's how it will be if we have added minus pi over 4. So it will be shifted, your graph will start from the positive side if we have added minus. If we are adding plus, it will be shifted from the negative side. I want you to take note of that. That is what happens with the horizontal shift. Okay? And now we look at periodic functions. What do we mean by period? Because you're going to have all of these terms in engineering. Period is any function of a variable that repeats its value in definite cycle. So you can have like a period like this when you let me just draw. You can have a period. Let me just put it here because it's easier to move. You have, I'll wipe it off. You have this, and then you have this. You start from here and here. This is a period. Okay? And then it can continue in this way and goes this way. This is also a period. Okay? So that is actually a period. The general form of a trigonometric function, I need to clean this. Okay, so the general form of trigonometric functions are a sine bs or a cos bs or a tan bs, depending on the function we're looking at. But what do we mean by A? A is actually the amplitude. If you go back, let me take you a step back. In this case now, in this graph, what is the amplitude of the graph? Can someone tell me? 1.
I think the amplitude is equal to 1.
Thank you. The amplitude is 1. And this is the amplitude. Let me just show you. This is the amplitude here of this graph. You trace this. This is 1. You see? That is the amplitude. And let's go back. So it's the maximum or peak y coordinate. It's the peak of the y coordinate, where b is the number of waves in one revolution. And what that simply means is the number of period in a full circle. Okay? And the period of the function is actually the smallest range of your x values that correspond to a complete cycle of the function value. So in this case now, if you're told to find the period, all you just need to do is remember a complete circle is 360 degrees, okay? Or you represent it in terms of pi, radian, which is 2 pi, and then you divide it by your b. This b can be 1. For instance, if you have y equal to, let's say you're given y equal to cos x. So what is the amplitude in this case? Can someone tell me what the value of your A will be? From this equation, A is 1. Thank you, Mazibuko. Then what is B? Can someone tell me what the value of B is from this equation? It's also 1. Thank you. Okay, and I would want someone to tell me, given this equation, sine 3x, what is the value of B? It's 3. Thank you. And from here, suppose we want to find the period. Remember, the period is one complete cycle. So what will be your period, T? Okay, Mazibuko said 120. Does anyone have any different answer? And how did you get 120? Yes, thank you, Talenta. It's 120. You divide three, you use this formula T equals to 360 over B. And here your B is 3. Okay? And it's just 360 over 3 and it's 120. I hope you all understand. That's how you have your period. That's what we imply by the amplitude, and B is the number of wave in one revolution. Okay, now we can proceed. So if we want to draw a sine curve, we rather use this equation, which is y equal to a sine bx plus c plus d. Note that we have included two things. We have included a vertical shift, and we have included a horizontal shift. So this is actually a complete equation. This is a complete equation because it has put into consideration your horizontal shift, which is plus C, okay? It has also put into consideration your vertical shift, which is plus D, all right? So let's take this example, and we want to sketch the graph of this example. We want to sketch the graph of 3 sine half x for one period. What does it mean? Can someone tell me what we mean by for one period? What do we mean when we say for one period?
So, sir, I think we mean a one complete cycle.
Yes. So these are the terms you might be seeing as we go on. We can say for one period, we can give a range from 0. We can also, let's say I've given a range from 0 less than x less than 360. Okay, this is also a complete period. We can say from pi less than x less than minus pi, minus pi less than s less than pi. This is pi. Okay, in this case, this is not a complete period. All right, so we can be given different range to consider. So in this case, we are given, this is the range from 0 to 360 degrees. So our amplitude here is 3, like we know. And B, remember, recall this equation. Y, this is what we're looking at, equal to amplitude sine x, sine b x, okay? Then we can add horizontal shift, okay? And then we can add vertical shift. I'm just representing, don't mind the representation, I'm just writing it out. And here now, our B is equal to half, as we can see here. We have not added any horizontal shift, and we don't have any vertical shift in this equation. So to find our period like we did before, our period T, all right, is equal to, let's say 360 divided by what? B, divided by B, half. Okay, or you represent it in pi, 2 pi over half, and that will be what? 4 pi, right? And that is how we found our period to be equals to 4 pi. Do we all understand that? The horizontal, which is C, is 0 because it's not given this equation. Vertical is D, which is 0. All right? And now we want to sketch this graph. How do we sketch this graph? It's easy. We draw a y and x axis, all right? And then what is the amplitude? What is the peak which our graph will attain? The peak which our graph will attain is 3. And you see, and this is a sine graph. It starts from 0, from origin, and keeps going. Remember, we want the complete period, in this case, is 4 pi from our computation. So our graph must go in a circle up to 4 pi. All right? And that is all. So what do we need to sketch our graph? We need to know what our amplitude value is, and we also need to know, oh, sorry, I said it's 0 to 360. That's not the case. It's 0 to 4 pi, not 360. Okay? Let me just take this out. We need to know our amplitude, and we also need to know our period. That is what will help us to sketch our graph to 4 pi. Okay. I hope we understand this example. Is there any question before we go on? Is there any question, please? If you have any question, you can just ask. Can we go on? I can have response from you guys. Can we go on? Can we proceed with the lecture? X more than negative pi. Mr. Adam, please, can you unmute yourself and ask your question? Because I really don't get it.
No, so I wanted to ask, like, why negative pi instead of 0? Like,
No. This other one I wrote here is just an illustration. It's not the example we're solving.
oh, okay, my bad.
This is just an illustration where I was trying to illustrate period. Okay.
Oh, so the
no.
other range is 0.
0 to 4 pi.
Okay. Okay, thank you.
Yes. All right. Thank you. Okay. Truly, what I mean, are we always given the value of B? Okay. I've got 2 questions that I'll quickly attend to. You see, from this equation, okay, let's go to a blank whiteboard. I want everyone to understand this. So so you can do it on your own and sketch on your own. When you have amplitude, when you're told to find the amplitude from a function, you can easily get it. When you're told to find the period, I want you to be able to do that without stress. All right, let's look at this. We want to sketch the graph of y equal to 5 sine, okay, 2x. So can someone tell me what is A? What is the amplitude here? Amplitude is 5. Okay, thank you. 5. And just to answer, who's that? Are we always given the value of B? Okay. Okay, now B. Truly, do you understand why A is 5? Truly, can you please unmute yourself? Okay. A is 5 because our general trigonometric function equation is A sine bx. Okay, now plus horizontal plus vertical, and that's the equation I've shown you. So you have this, and A in this case is 5. Okay, B therefore will be what? Truly, what is the value of B from this equation? From this. Truly, we are waiting. What is the value of B? It's 2. Okay, because you can see from the general expression that B is 2. All right, so that's it. If we are, okay, and then what is the value of H? And what is the value of V? Can someone please tell us what is H? Yes, H is 0, V is 0. And that's it. That's actually what we have done in that example. I hope that is clear now. We can move forward. Yeah.
Sorry, sir.
Okay.
If we are not given a range where our graphs start and end, we will divide a period. We will use 360.
Yes. So it will just like you have been you have your period is 360 over B, or is 2 pi over B, right? So that is how you get your period. Okay, let's say your B is, let's say you have been given an equation that is y equals to 5 sine x. In this case, remember your B here is 1. Then what your period will simply be 2 pi over 1, which will be 2 pi, okay, or 360. So if you want to sketch that graph, you just simply sketch the graph from 0 to 2 pi. And that's going to be, this will be pi. Remember, it's half. So it's from 0 to 2 pi. So whatever your p value is will be used to determine your t. All right? Does it answer your question?
Yes, sir. You can proceed.
Thank you. So going back to our lecture, I hope every other person understands, because it's important for you to understand. We may be needing this sometime soon, later on, or you're gonna have it in most of your engineering course. So this is another example, all right? And in this example now, we have been told, let me go here so I can see what you guys are asking. Okay. Someone says, how do we get H and V? It will be given actually in the equation. If you have been given any value for H, that implies you will be doing horizontal shift. if you've been given any value for V, that means you'll be doing vertical shift. And look at this example 2. It says sketch the graph of y equal to 3 sine x, okay, plus 3 sine 2x, and note the range has been given. You see? You have been given this range. So basically your graph, I will clean this up. Your graph will basically be like from 0 to 2 pi. So wherever you're sketching falls within this range. All right. So to go with the solution, first thing, I've actually written it out so that you guys will understand, and when you're reading on your own, you can actually go back to this. The first thing is to construct the graphs of y1, and this is y1. What I mean by y1 is here, y1, and this will be y2. And your y will simply be y1 plus y2, of course. So the first thing is to construct the graph of y1, which is 3 sine x, and construct the graph of y2, 3 sine 2x. You then construct these two graphs on the same axis. And from our example, we know already that our A in y1, A is 3. This is from y1. And in y2, A is what? 3. Okay? And we have been given the range already. So now you have to construct the graph of y1 now. That's easy. Your B in y1 is 1. So you simply sketch, and you've been told you have from 0 to 2 pi. So this is pi. All right? That will be the graph of sine x. Now you want to sketch the graph of y2. Before I forget this, my amplitude is 3. So this is 3. Okay. For y2, it's going to be 3 sine 2x, and your b in y2 is what? Is 2. Okay. And in this case, your periods may be, t rather. T will be 360 over 2. That's 180. Okay. So that makes it tricky, because you're going to have this, which has a period of 180. Okay. So what is the next step? Find the y value corresponding to each x. Remember, there are 2 different x now. That is, find y1 value for x and y2 value for that same x. You will see how that is done. I've sketched the graph. Add the 2 values y1 and y2 together, like I've written here. Now let's go to the solution itself. So that I don't waste time. For x, look at this graph. Let me do this and then do this. Okay, let me reduce the points. Okay, now I want you to take note of this graph. Look at this. You see this graph that I'm tracing? That's the graph of what? The graph which I have traced with red dots is the graph of sine x. Thank you, Mazibuko. All right. I hope we all agree with that. Okay. And let's go. I hate this thing. Okay. And let's now trace the value of x at OA1. OA1 is 0, A1 here. The value of x is here, is at this point. Okay? For y1, it's A1, B1. Can we see it? The value for x at 0, A1 is at A1, B1 here, this line. Now let's do for y2. Y2 will be A1, C1. Okay? Now, if you trace this value here and here, this is 0.5 from the way it is. Let me just trace it to this axis. This will be 0.5. Okay? And here, no, C1 is here. This will be, what value is this? Trace this. This will be 2.5. Now add this together, will be 3.0. Then you see the addition is here. And it's D1. Remember, you have sketched the graphs of x. You've sketched the graph of sine x. Y1 is sine x. And the graph of y2 is what? 3 sine 2x. Okay? And the amplitude here is 1. A for y1 is 1. For y2, A is 3. Okay? And that's why we have this graph for y2, like this. If you look at it, if you can do the sketching on your own. And then what we want to observe, to plot or to sketch the graph of their sum, is at each point A1, we have the value of 0.5 as the amplitude. For the second function, 3 sine 2x, at point A1, the y value is 2.5. When you add it together, you have 3.0, and that tells you their sum. You see, D1 will be there. Now let's look at this. At which point again can we trace? Let's look at A2. All right. At point A2, what value do we have for B2? It's here. Let's say that is 0.8. And you trace the same point down to Y2, which is here. This would be minus 0.5, thereabouts. When you add it together, you're going to have your value for D2, because D is for the sum. This is what? This value plus this value, sorry, it's here. That's minus 2, let's say 2.5. So you add this together, you're going to have, what value is this going to give us? 0.8 minus 2.5. Minus 1.3. Do you see? That is the value for D, their sum. Okay? And you continue with that until you get to the end, which is 2 pi. And when you take a sum of it, these two at 2 pi, let's say we pick this point is 0, and then for y2 is 0. So their sum y, which is y1 plus y2, when it's 0, 0.0 as 0, and you got it here for their sum. I hope we all understand. Now, that is how you do the sum of two functions. Okay, that is how you sketch. It's a sketch, remember. You are not plotting actually the real values. You are sketching from two functions that have been given. You want to sketch their sum. You want to sketch their subtraction. Let's say this is y equals to sine x minus 3 sine 2x. What are we going to do? So what is going to be y? Can someone tell me? Y would be what? Y1. What sign are we going to have here? Minus y2. And this is how we're going to sketch the graph of this. So it's a sketch. You sketch it from the functions that have been given to you. All right? Do we understand? Are we clear about this? Can I move forward?
Sorry, sir.
Okay.
Sorry, sir. Is this the only way to find the y values? Because it tricked me a bit. The y values for the sum of the two functions.
This is the easiest way to sketch it. And I want you to go practice. Okay? Practice. If you need help, I've told you at the beginning of the class, please request for a tutorial section. Okay? I want you to go after this class. Practice. Someone say I'm also confused a bit. How did we get minus 0.5 and 0.8? Minus 0.5. Let me just clean all of this. There are a lot of... I'm afraid with the way we're going, we may not end today's class the way I want us to finish, but yeah. Okay. I'll quickly take it over again for those who may be confused. Okay, can we just take it over again? Remember that we have plotted, or we have sketched first the value of y1, the graph of y1, and we sketch the graph of y2, all right? Which is y1 is this sine graph, y2 is the dotted graph, okay? Now, we want to look for y, which is the sum of y1 and y2, all right? And how do we do that from our sketch? What we're simply going to do is you pick points, okay, on your y-axis, and you trace it. Okay, let's say I'm picking, ignore A1 now. Let's say I'm picking these points.
I'm sorry, sir.
Yes.
These graphs for example, y1 It's the sum of the graph we're given at the beginning, right?
y1 is y1
Isn't it supposed to be 3
is
sine x?
sine.
What
No,
was the
y1
amplitude?
is sine. Y1 is sine x. Y2 is 3 sine 2x. This is y1, and this is sine. This is y2.
Mm.
They say that, and the procedure says sketch the graph of y1, which is sine this one, this. Okay, this
Okay.
is the first, that is for sine x. Now sketch the graph of 3 sine 2x. Okay, and our amplitude is given as 3 for y2. So the dotted one, the peak is at 3. That's the amplitude. For y1, the peak is at 1 because that's the amplitude. And then you sketch that up to your 2 pi, okay? Now, we want to do the sum to find y, to sketch for y. And how do we do that? We pick a point. Let's say we pick this point here, okay? Trace that point to this peak, not to the peak, just trace it to this, to the graph, to the curve, and then trace it back to the y-axis here, okay? And let's say the value here on the y-axis is 1.8. Let's say this value, let's say the value here is 1.8, okay? And then trace at the same point, okay? Remember, you have selected a point on the x-axis. You're tracing it up to your curve. You trace it up to the first curve, and you trace it to the y-axis. Let's say it's 1.8. You continue tracing this same point up to your second curve for y2. And then it's here. Let's say this is 3. Then you trace it. Now you see, I know this is 3 because I've traced it to this point. It's 3. So what I just do is you had 3.0 plus. That will be 8, 4.8. Okay? So what this means is the addition of these two functions, they are the curve, which will be at this point on your x-axis, will also be at 4.8. Let's say it's here. I'm just saying, let's say this is the point. So this will be 4.8 on your y-axis. Pick another point on your x-axis. Okay, let's say we have picked this point, half pi or wherever. Yeah, half pi. Trace it up on the first curve, and here it's 1.0. Trace this same point up on the second function or the second curve. It's here. Let's say this is 1.8. I'm just saying this point. It's 1.8. I hope we are following. Then when you take the addition, it's 2.8. That means at half pi, oh no, sorry, it can't be 2.8. I did a wrong one. I'm doing for half pi, right? The second curve is 0. Is 0, not is 0. So that will be 1.8 for this. So by the time you trace this up, you'll be having, at this point, will be 1.8. And this will be, remember, you want to sketch a graph. This is like this now, or like this. Now, you pick another point. Let's say we have picked this point. Trace it to your to the first curve. It's here. Let's say that is 1.8. Trace it, your second function is here. and this is, let's say, -3. Okay? Then you do this. This will be is a 1.8 minus 3, whatever value that is, will be here. Okay? And you continue to trace till you are able to sketch now your new graph. Let's say this is our new graph. So by tracing wherever thing you had traced, you'll be able to form your new graph like this. Okay? So it's just like you obtain the sum of two functions from their graphs by tracing the same point on the x-axis and tracing it to your y-axis and using that value, the addition, to sketch your new graph. I don't know if that explanation is okay. I think we need to proceed. You can request for a tutorial session for this. Okay? And please keep practicing. By the time you practice one or two examples on your own, you will actually see what I'm saying and you understand it better. I recommend you practice more of that. I strongly recommend you practice more of that. It may be coming out in your test, please. Now we want to look at basic relationships and identities. You have been taught about trigonometric functions, you've been taught about ratios, and now what is the relationship between these functions? And that is what we are showing. Already you know cosec of theta is simply 1 over sine theta. You already know the relationship between sec and cos. You know the relationship between cot and tan, all right? Those are called reciprocals. Now, you also know the relationship between sine, cos, and tan. If you have tan theta, you can represent it as a quotient, is sine theta over cos theta. If you have cot, which is 1 is a reciprocal of tan, right? Then you have cos theta over sine theta to represent cot theta. That's a quotient. Now, we have also mentioned Pythagoreans. This is a theorem that finds the relationship between sine, or the addition of sine, and cosine. Okay, you all know that sine squared theta plus cos squared theta equals 1. And another Pythagoreans is 1 plus tan squared theta equals to sec squared theta. These are constant equations that you will be using in simplifying area of finding the size of a triangle, finding the angle, a missing angle in a triangle, and all of that. I think you remember that. It's just to recollect. Now, we want to solve problems using this relationship. Let's look at quotient and Pythagorean relationships. Sometimes you may be told to prove, okay? And to prove means to show that this and this is equal, or this and this exists, or this and this is true, okay? So in this case now, we want to prove this quotient relationship between 1, tan theta, sine and cos, and 2, cot, cos, and sine, all right? It should be a straightforward thing to prove. Let's say you're given an angle theta. You'll know that sine, using SOHCAHTOA, sine is what? From your SOHCAHTOA. Okay, thank you. Now let's use the same xy. Okay, let me call this x, and this y, and this r, and this is the angle. So it's opposite over hypotenuse. Thank you. And what is the opposite? It's y, and the hypotenuse is r. Okay, and that's, you just to refresh your memory, you have sine theta is y over r, cos theta is x over r, and tan theta is y over x. Okay, cot is the inverse, which is x over y, and that is where p is xy. All right, and it's from origin 0, and r is the distance. So all of this just to be able to prove tan theta equals to sine theta over cos theta. Now let's go with tan theta. Remember now that tan theta is what? Is y over x, and that's, I'm showing this again because it looks tiny. Y over r, okay, divides by x over r. Let's see how true this is. Y over r. Sorry, let me just open another blackboard. Before we proceed.